And we're back at the morning show. It is one of our favorite times of the week, Wise Guy Wednesday.
Matt Selen joins us again from the U of I with an experiment that'll put you over the moon. We're talking about atmosphere and pressure and all kinds of good stuff, Matt.
Hi, Matt. Hi, Robert.
Hi.
Last week I asked the following question. I asked, is it easier to suck liquid up through a straw on the Earth or on the moon?
And I had a guess here. I'm going to guess that... I have two guesses. My first guess would be that it would be easier on the moon. The second guess would be that it's the same in both places.
It's actually easier on the Earth.
Wrong and wrong.
Which is why I don't teach physics.
And Amanda Reed and Rantoul got this one right. Very good answer. And it's pretty easy to explain that. You might think it's easier on the moon because the gravity is a bit smaller there, but it doesn't have to do with gravity. It has to do with atmospheric pressure. And the reason that you can suck liquid up into your mouth from a cup has to do with the pressure of the atmosphere, actually. So I can illustrate that right here. Here's some iced tea, which is in this glass. And when I suck this up, yummy. What happens is I really create a bit of a vacuum in my mouth as I draw the liquid in. And so I have atmospheric pressure pushing down on the liquid. I have a smaller pressure in my mouth because I'm sucking. And so the atmospheric pressure down here pushes the liquid into my mouth. That's what happens. And I can prove this. It's the pressure difference by just blowing into this. I have a little saran wrap over this glass. So just in the same sense, what I can do is I can blow some air into this cup. That'll make the pressure here higher than outside. And it makes the liquid and the straw come flying out too. Okay? So it's a pressure difference that makes the liquid move. And in fact, the pressure difference has to be big enough that it can actually overcome the force of gravity. And so the smallest pressure you can ever have is 0. Okay? And so even if you suck as hard as you can, the pressure difference between inside and outside can't be bigger than 15 pounds per square inch. And that means you can never actually suck water up a straw higher than 34 feet, in case you were asking. So, okay, so anyways, on the moon, this made me think about what happens if you're on the moon. And so what I have here, I can illustrate what happens to you on the moon by this little marshmallow man, which I've made. And I haven't thought of a name for him yet, but he looks kind of like Mr. Bill. And what I'm going to do is I'm going to place this glass jar over the marshmallow man, like this, and there's a greasy seal there so that we can pump the air out. And keep an eye on the marshmallow guy now. So what happens is we're sucking the air out of this bell jar. Since there's no atmosphere on the moon, okay, we're simulating that condition inside the bell jar. And you see that this guy is kind of expanding, and he's getting kind of large, which wouldn't be a very pleasant thing to happen if you were actually on the moon trying to suck things up through a straw. And what's even more interesting now that some of the air has escaped from these marshmallows, if I let the air back into this jar, you'll see that the poor old marshmallow man gets sort of smushed. So he's a very depressed marshmallow man at this moment. I think you'll have to agree.
You know, that same sort of thing happened in a science fiction movie with Sean Connery, and I cannot remember the name of it.
Yeah, there's all these movies where the guys go out into space and their eyeballs fly out of their heads and stuff like that. And that's sort of what happens if there's no vacuum. Then the pressure inside your body tries to get out, and it's not a pretty thing at all. But basically, what happens is on the moon, since there's no atmospheric pressure, you can't drink through a straw at all. Not to mention the fact that you'd look like this after a while. So it's not a good thing to stand on the moon and try to drink. That's my advice to you.
Excuse me.
The marshmallow man couldn't handle the pressure of your experiment?
That's right. Oh, and yeah, that's a good one.
And the winner, or the correct answer person, gets one of your T-shirts, right?
That's
Amanda?
right. That's right. And let me ask a question for next week.
Okay.
We all know that water boils at 100 degrees Celsius. That's sort of the definition of the boiling point. And can you think of ways that we can change the boiling point of water? And if anybody can send me some good answers, then they'll win a T-shirt for next week. So how do you change the boiling point, or how can you make it not boil at 100 degrees?
Does it involve liquid nitrogen?
It might. I'll see if I can make
liquid nitrogen is good. And Matt, I have to tell you that my first guess was the correct answer on that, but I was talked out of that in the newspaper.
Always go with your gut feeling.
Yeah. We're making